Okay, so hi all. So this is going to be our week 2, day 5 of GCP Google Cloud Fundamentals training. And the topics that we are going to cover today is Google Cloud Database Services. So we are going to discuss in the similar pattern that we used to follow in previous sessions. So we'll talk about the introduction to Google Cloud Databases. Then we'll define the databases based on how they classify the different types of these databases. Next, we will see the various database options available on Google Cloud, and at last, we'll end up with what are the decision tree or how to select which database is going to be right for the use case that I have in my hand. Okay, so let's go and see what we have for today. Yeah, okay. So the very first database that we are going to cover is going to be Google Cloud SQL database. But even before that, let's have a detailed structure, or let's see on high level how many database we have, okay, and then we'll come back. So let's see another screen. Okay, fine. So I hope you can see this screen where I have listed on the graphics that is provided by Priyanka Vargadi ma'am about what are the databases that is available on Google Cloud, and there is a kind of a segregation where they align, right? So first of all, this database, whenever we are talking about the databases, they have some sort of structure or they don't have any structure, right? So earlier we used to have only a structured databases, and we know that they are called the relational databases or the transactional databases, you can say. So they were very much depending on a particular schema, and based on that, you were storing the data in it, right? So even just before this session, we were talking about the block storage where we did not follow any structuring, right? Now, in this case, we are going to see some sort of schema, or you can say either they are going to be fully structured databases or they can be partially structured. Like you have the flexibility to define your own schema and try to store the data. Just because you want to have the right way of retrieving the information out of it, or storing the right way, so that you can actually make more better enhancement or better analysis of your data whenever you want to perform a later point of time, right? So now, if you see on very high level here, we have two relational databases. So whenever we say a relational database, what do we mean? I mean, they are nothing but these databases have relations established between the data that we have stored. Like if you see, we have a table structure. In the table, we have a row and column. Now they can be, I mean, the columns that are defined, they can be uh, having a relation with another table as well. So they are somewhere becomes tightly coupled, or at times they can have some sort of flexibility, but you have to define that. So that has to be defined, and that's where we say that they are relational, or you can SQL one, right? So that is how we go about it. Now here in the relational one in Google Cloud, we see we have a Cloud SQL database first of all. Okay, then we have the LOIDB, which is again I will explain what it means. For now, let's park it like we have the Cloud SQL and the LOIDB as two relational databases. Okay. The next one is a relational and as well as a non-relational, because it is something that Google has developed by its own, like their proprietary database, which is called Cloud Spanner. Okay? Again, it has its own advantages. I would say there can be some disadvantages, but mainly they have a lot of advantages. Okay? Okay, so the next one is non-relational database or the NoSQL databases. Like you don't have to follow a specific SQL query to insert or retrieve any information out of it, right? So they don't fall under the structure one. So that is where we have two options. One is Firestore, another one is a Bigtable. Okay? There is one more type of database which is very much added as like a memory optimized. They are more performant in a scenario like temporarily they store the data for some time, and like you have some compute intensive work that you are doing, like you are someone who is actually working with the gaming a lot of the time. Okay, So that is where whatever sort of information we want to store, that we are using a memory store. Okay. And there is another category which is bare metal. Now there are some sort of databases which cannot be completely migrated or created on the Google Cloud platform, for which, like, the example is Oracle. So Oracle has its own set of schemas, set of specification that is not probably made a compatibility with the Google Cloud, or the kind of agreement they have that do not allow to take all those set up with them, right? So now, as these are very vastly used databases, Google has to come up with some solution which can support this Oracle database also on the Google Cloud data centers, right? So they had to come up with a bare metal option, like it's a completely hardware based. They will provide you a complete setup on a separate data center, which is somewhere, you can say, linked with the Google's own infrastructure, but they are not present in the Google's own data center. I mean, they are somewhere integrated with the third party or some way like that. Okay, so these are some of the complications because of the contractual limitations they have. Okay, so on again, just to revise it. So we have relational databases, non-relational databases, in-memory database, and there are bare metal databases. Okay. So let's go back and understand what is Cloud SQL, and then from there we'll move towards the app spanner database, file store, big table, memory store, and bare metal. But the Oracle DB, we are not going much deeper on Oracle DB. Only thing that I want to cover here itself is that this is addition to this cloud, I mean, support to the Cloud SQL database. Only thing is that it only supports for PostgreSQL DB. Okay. Postgres, I mean, there are multiple databases that you must have heard of or used somewhere in your own work environment. So PostgreSQL is the one that is supported by AlloyDB, and it is giving me 4x faster transactional queries compared to the Cloud SQL. That's the only advantage that you're getting. And there are more, because you are getting the SLAs defined. The data storage is defined different way as compared to the Cloud SQL. But for now, only information that you need to collect for AlloyDB is that it is based on PostgreSQL only, and it is providing me 100x faster analytics compared to Cloud SQL, and 4x faster transaction queries. Okay. Now let's go back to Cloud SQL. Okay. So I hope you can see it clearly, right? So now in Cloud SQL, if you see, this is a fully managed relational database which supports MySQL, PostgreSQL, and MS SQL servers. These three databases are supported by Cloud SQL. So just take it as uh, a managed service which is providing me an instance. Instance becomes, again, if you compare it with the virtual machine instances, good enough. Okay, just try to relate it with that. So now on those instances, I'm going to create databases. I can have multiple databases, right? So these instances are not serving for anything else but only for databases, right? So purpose driven only for databases. So let's see how it works. So whenever you are going to create any of these Cloud SQL instances, if you see, again, it says that it is going to be regional. I mean, the region plus the zone, that is what it says. So it is again a zonal resource because it is running on one instance, which is very much limited to some zone. I can have multi-zone enabled. Okay. And then whenever I'm creating it for multiple zones, it becomes a regional resource, but it cannot be multi-region. Okay. So only thing is that it is enabled till a region, not multi-regional. Okay. So in a region, I can have multiple zones for which the replicas are created using the high availability options. Otherwise, it is limited. Okay. And in case of Cloud SQL, we are storing the data in a SSD or HDD. Like we saw this persistent disk in the compute engine case. Remember? We talked about the persistent disk.
Yes, you have talked.
Okay. So as these are running on an instance, like similar to virtual machine instances that we create, so they are storing the data in a SSD or the HDD or the persistent disk that we have talked about earlier. So that is what they are talking about. Now, for high availability, automatic failover to another zone or region can be done, but for regional availability, that is only create the read replica, not the write replica. Okay, so let me explain what are these. First of all, do we understand what is high availability?
That means
Anyone?
copy will be there. Okay. So whenever something will be down, automatically it will fetch the data from the second one.
Right. So whenever we design the failover scenario, failover in sense, I have a primary database running. In case there is a failure, it should revert back to the secondary one or secondary, or you can say the standby one, right? And that is how we ensure there is a high availability design for my databases. Okay. Now, so here also we are going to design that the failover. And if you see, Naresh, for you also, if you understand here, so if you see, these Cloud SQL instances are created as in single zone, right? Now, in one zone, if suppose there is a failure, it will here, this one I'm talking about. I hope it is clear. I mean, you are able to read it fine.
Yes,
If not,
zone
let
A,
me know.
zone B.
Yes, zone
Yes,
A and zone
automatic
B.
failover. Yes.
Right. So automatic failover happens, and these are the managed services. That means Google Cloud is taking care of it as long as you have enabled or just ticked that I should have the high availability enabled here. Right. So that is how it works. Now, now let's see what are the use cases of these Cloud SQL instances and the databases that we are hosting all those instances. So it allows you to connect with the multiple other services, like we can see App Engine, GCEs, that is Google Compute Engines. Okay, then Cloud Run, and the Workstation is another service which is again similar to, you can say, designed for to give you a workstation like a compute engine itself, but it is giving you an option to work dedicatedly on your own environment only. Okay, so there are multiple integrations internally happening within the Cloud SQL itself with the Cloud SQL and the Google Cloud Platform. Okay, okay. Then you can migrate your existing workload to the Cloud SQL. So this is very important. So whenever we are starting any migration process, what we do is first, which is easy to design and easy to start with, is start with moving the data, because as soon as you migrate your application, you need the data. So that's the reason we should start with the data first, and that is where I need to know what are the ways I should be able to migrate my data to the cloud. So here I have the option, like I can migrate existing MySQL, Postgres, or MS SQL databases to the Google Cloud, and where we are going to migrate, it will be pointed to the Cloud SQL. Okay, because that is where it is giving me more compatibility and fulfilling my requirement. If it is going to be much larger workload or much higher size of your databases, obviously you will go for the another solution that they have, that is Cloud Spanner. So these two are Cloud SQL, Cloud Spanner. These two databases are relational. Okay, Spanner is somewhere non-relational as well, but still it is supporting all of those components what is required for the relational databases, or you can say what is needed for the Cloud SQL. Okay, there are some premium charges because it's a proprietary product from Google Cloud. Fine. Okay. Now, from security perspective, again, all of this data is encrypted at rest, and even when we are retrieving it, like when you are the data is in motion. Okay, so when we are storing the data, when we are retrieving the data from it, all the time it is encrypted. And we know the multiple ways of encrypting the data. Either you use Google's default encryption method, or you bring your own I mean, you manage the keys that is used for encryption, or you bring your own encryption keys. You are supplying the encryption key, you are doing all sort of things for encrypting your data. Okay, from pricing side, again, if you see, you are getting charged for the instance that you are creating. Okay, because that is going to be present all the time. The amount of CPU that is being used, the amount of memory that it is going to keep, the storage that you are taking, and also there will be a networking cost. Like whenever you are going to access the databases, it is passing through some network to give you the access, right? So there will be a charge for that network. Fine. Okay, now here is an example of it. So if you see, online transactions like the OLTP transactions that is having, frequent queries are happening. Okay, for that we need it. So fast response times are required. So all of these scenarios, we need the Cloud SQL instances. Here, if you see this particular architecture, okay. So here, if you see, here I have an application deployed in a Kubernetes pod. Okay, and it is trying to access the database, the Cloud SQL database, and it is interacting with the, you can see, primary instance. You can see that primary instance we are talking about. Now, whenever it is going to interact, right? I mean, it is going to save some data, it is going to retrieve some data. Suppose it is saving some information here, some data it is saving in the Cloud SQL primary instance. Now, at the same time, whenever we have enabled the high availability, it is going to ensure that the data is getting replicated to this particular secondary database also, right? Just to ensure whenever there is a zonal failure, okay, I should still be able to access my data, because now it will fail over to the secondary instance. Okay, so secondary becomes the primary, and I'm still able to access my information. Okay, that is how it works. Now, when there is a, I mean, whenever the zonal failure is over and it is up again, now again it will revert back to the primary one, and the primary instance is up again, it becomes secondary again, and that is happening automatically. You don't have to do anything, just have to enable high availability. That's all. Okay, so this is all about the Cloud SQL. Any questions so far? Anything come in your mind?
Okay, one question, Jitendra.
Yes.
Okay,
yes.
so whenever migration is happening, first we were migrating the database, correct?
Yes.
Okay, so can you give the end-to-end connection on a one line? Suppose that what are the things we have to prerequisite to start the migration? Because sometimes it is a common question they are going to ask. Okay, you have to migrate the database from on-premise to cloud. What are the pre-check you will do?
Okay, see, here if you see, read it out, this is very much summarized form. Okay, so what you need to do, you need to first of all define what is your data source, from where you are bringing this data, right? It can be coming from your on-premises or maybe from the another cloud, right? So you need to first define that. Once you are having that information, now you need to create a network connectivity between those two source and the target is obviously going to be our Cloud SQL in this scenario, right? Clear so far?
Clear.
Okay, now let's move next. So what we are going to do as a primary, so here if you see, we are creating a Cloud SQL read replica. What does it mean? The read replica here, if you see this failover, we were creating this failover is different thing. The read replicas are a little different thing here. So read replicas are nothing but you are actually duplicating whatever data you have or the data you are saving in your primary instance or your cloud or your database, right? So now you are just keeping a copy of it, keep on duplicating it as long as only a delta amount of data remains there. Okay, so I have created another copy on the cloud. I'm not using it for any time. I'm just keeping a copy there till the time all the bulk migration is done, all the bulk of that data is copied from previous days, years, everything, right? Now I'm left with, whenever I'm going to migrate, no, so now I'm left with maybe 2 days of data, maybe a day of data, or a few hours of data, right? So that I need to now move it, promote it to what I can say. See, there are tools which is actually helping you to continuously replicate your information. Okay, so you have to keep up some amount of a downtime, not downtime, I can say. Yes, in reality, actually, there will be some amount of downtime, but on high level, I would not mention it as a downtime. But what we do is there are some software or the services like database migration service that is provided by Google Cloud and other cloud also. So what they do, they are continuously replicating your data from the source that you want to migrate to the target like Cloud SQL database, right? So you have to define the source, create the network connection between them, start the replication, right? And when you find the suitable time, or whenever you decide that okay, now we are ready to cut over from the on-premises or the other cloud to the Google Cloud, on that day we will have all other set of planning done, ensuring that the application which is going to communicate and all those are migrated, everything, right? So that is secondary part, that you have to plan anyway. But on that day, you will be promoting your read replica, the read replica that you created on the Cloud SQL, right? That you will be promoting as a primary instance, right? And then you are done. That is how it is done. So we do have some sophisticated database migration tools, which will ensure that all the data is already copied. Now, whenever you find a suitable time, you cut over to these Cloud SQL instances. All done. Okay.
Okay. Yeah. Can you tell me any tool name?
Yes, I just told database migration tool, database migration service.
Okay,
DMS.
that is the tool name. Okay.
Yes.
Okay.
Okay. Fine. So let's move next and look into some other ones. Okay. So we are done with the Cloud SQL. Let's talk about Cloud Spanner. So as we have seen, Cloud SQL is somewhere zonal and it is limited till the regional resource only. Now, when we are talking about the Cloud Spanner, it is a regional as well as a global resource. Like it can be accessed from any region, okay, in the world. Okay, so it is giving you a global consistency. Again, it's a relational database, has a proprietary formatting, the way of storing the data. Okay, there are a lot of logics behind it, okay, which we are not going to discuss in much detail, but you should just know that these are a proprietary database provided by Google Cloud. Okay, they have a way of I mean their recipe of saving the data on the cloud. Okay, it is providing you much better high availability and scalability because it's a global resource. That means the data whatever you're going to store, that can be stored into multiple regions, very highly compact, okay, easily accessible. Just that you have to design your schema so well, the data which are similar in nature or which you are going to access together, make sure they are saved somewhere near to each other, right? So that is how it is going to be making more access to it. So also, if you can read here, it says that zero downtime for planned maintenance and or the schema changes. So there will not be any downtime when you are opting for the Cloud Spanner, right? And there can be multiple use cases. I can talk about like everyone must have used Google Photos, right? Did you use Google Photos?
Yes, yes, yes.
Yes.
So it is storing your data on the Cloud Spanner.
Okay.
Okay, a real-time use case I can talk about, right?
Okay.
So yeah, so that is all for this particular database. Yes, you can see that availability and all is very much high level. Like you can see 99.999, that is 5 nines we call it. So 5.9 SLA is provided by this particular database. Now there are formulas which help you to calculate what does it mean. Okay, so SLA, I mean, if you have heard of the term SLA, it is service level agreement. Like if the data is not accessible for the agreed timeline or agreed agreed timeline only. So if it is not accessible in that particular timeline, then the cloud provider has an obligation to pay them based on what we agreed upon, the amount that we have agreed upon, right? So that is where SLA terms come up. Now 555 is a big kind of commitment, because it is like I think monthly there will be around few seconds of downtime only, if you try to understand in that sense. We'll try to cover that, or we'll try to show how to calculate it, but they are again some terms that you should be aware of. Okay, fine. So let's move on. So far we covered the relational databases. One is Cloud SQL, another one is Cloud Spanner. Cloud SQL, three databases it supports: MS SQL, PostgreSQL, and MySQL, right? Cloud Spanner is a proprietary database. You can even migrate your data from on-premises to the Cloud Spanner directly, either it is MS SQL, I mean MySQL, Postgres, or other database, right? Even from Oracle also we can migrate to the Cloud Spanner, that I'm aware of. I have not worked on it, but I'm aware of it can be achieved. Okay, fine. So let's move on to the next database, which is going to be what? The bare metal. Okay, so let's see which one is now bare metal. Not this one. Okay, so first of all, what is a bare metal? Did you ever heard of bare metal anytime?
Yes.
What is it?
In the hardware itself, we are installing the virtualization on that.
Right. So it's actually the hardware itself.
Yes.
Okay, the bare metal means hardware itself. So it is meant for the specific workload only. Like in case of Oracle database, if you see, they are not agreeing to provide all that. I mean, whatever their infrastructure is required, they are not okay to move everything to the Google Cloud. So now what they have come up with, like let's have their extended data center, which is somewhere linked with the Google Cloud's infrastructure, but they are not present in Google Cloud's premises. Okay, they are present somewhere outside. Now there is a connection that we are establishing between those bare metal or the Oracle databases to the Google Cloud network, and then from the Google Cloud network you are trying to access from your system, right? So there is a two layers, you can say. So you need to pass through the Google Cloud network, and then Google Cloud network has a connection to this Oracle databases, right? So that is how the connections are established, and that's how we are able to use or cover the use cases wherever there is a need for providing the support for Oracle databases also. Okay, it's really a kind of a complicated setup that we do. I did have an opportunity to implement it like through during the similar sessions, you can say instructor-led sessions itself. So that is how I got to know how to implement it. There are some additional softwares we need to be using. Okay, but once you get this installed, or once you get it connected to the Google Cloud on premises, the advantage that you get is you have the opportunity to bring your own license, perform the better security of these databases. Okay, because whenever you are bringing to the cloud, we want to ensure that what advantage they are giving to us, right? Otherwise I have that option to use the Oracle database on the other from the on premises also. So what is additional that cloud is providing? So you get licensing, security, logging, monitoring, maintenance, backup, application support, everything you get when you migrate to the cloud or the Google Cloud, right? Okay. Also here, okay, so you can see this particular regional extension. That's what I was talking about. So it is not present in the Google Cloud's on-premises, but it's an extension to that region. Like wherever the nearby regions of Google Cloud is present, it is going to be linked with those regions, and that is how you are accessing it. Okay, so very much on high level, or the kind of information you needed for now for this particular database, it is present here. Okay, so this is the Google Cloud's infrastructure, and it is connected with the regional extension for accessing the Oracle Cloud, and Oracle Cloud is installed on the bare metal. Okay, you can see this infrastructure, which is uh, the Google Cloud infrastructure, where you have the compute engine, GKE, cloud storage, firewall rules, everything is actually able to connect with this database, and then with very low latency, because obviously it is connected with the internet. So when we are going to cover or the talk about the networking, we will understand what does interconnect means. Okay, for now it is like a very high bandwidth network connection. You can say like 10 Gbps or more than that. Fine. Okay, so let's move on. So now we are done with bare metal. Next, we have to talk about the Firestore. Where is Firestore? Okay. Have you ever worked with any one of you? Have you ever worked with MongoDB or any sort of document database? Any other name that you can recall for document databases? No one? Okay. So let me try this way. Naresh, where do you save your? Which database you use whenever you are developing these mobile applications for either of these, maybe iOS or the Android?
Are you saying locally on mobile app?
Yes.
For mobile app, we use like SQLite database, and
Okay.
is there.
Okay. So it helps you to store the data locally on the mobile, but whenever it becomes whenever you are connected to the internet, it will try to save to the somewhere in the data center also, right?
Yes, we keep backups.
Yes. Okay. So similar to that, Firestore also works. So earlier, this is actually kind of acquired organization. So Firestore is a name that Google Cloud has come up with, or probably this is Firestore is an organization itself. Earlier, they have another version also, like Data Store, which is very much compatible with the mobile data and web application as well. So suppose like you must have seen that you are working with some of the application, you are trying to access something on your mobile, and suddenly the internet is gone. Okay, now you are not able to connect, but the data is not lost. As soon as the network is available, now it is synced up, right? So what it is doing, it is saving your data offline on the mobile network or the web application, and then syncing it asynchronously to the on-premises or the other the cloud data centers, okay, or the database. So these are the document database first of all, okay, and it is used to build the data-driven apps quickly. That is what it means. So not much bigger concept here. Only thing is that it is a document database. Like you are profiling. You suppose you are storing some of your information like your name, the kind of your shopping list, right? So then your other details like your age, all those are kind of your profiles that you create whenever you are accessing any application. Most of the time we have seen when you are actually using maybe Amazon app or what else I can say, any gaming app that you use on the Google Cloud, I mean on the Play Store you install and then you try to save those information, right? So all of that is actually behind the scene using Firestore. Okay, so actual company name was, if you see here, they it was Data Store or something, and then it was named to Firestore, I believe. Okay, so they have two different models, like one is offline and the other one is an online model, and that is how the data is being stored. For now, you need to just understand this is a NoSQL document database. Okay, and as it is provided by, or the support is provided by the cloud, it becomes more of fully managed and serverless. Okay, so these are the keywords that you need to be aware of whenever we talk about the Firestore databases. Okay, here you can see how this data is stored. So as I was talking about the profiling, so your data is stored as a document. I mean, you have suppose on the higher level you have this particular, okay, you have stored your name. Okay, now as I have stored my name information, after that that name becomes the root. Okay, and below in the, when I go down, I will be storing more information about me. So I have my name. With that name, I'm going to link my age, my qualification, what is my skill set, what kind of movies I'm liking, right? All those informations you are going to save in a format which is going to be accessible very easily for me. So this is a kind of a document databases, okay, and that's what Firestore is about. Again, it also has a very high SLA, so you are getting the triple, I mean 5 nines SLA for this particular database as well. And most of the time, it is used as a backend as a service. Okay, and mostly working for the web application and mobile apps. Only these two is on very high level that we use this database. Okay, so that was about the NoSQL, but also as we are talking about this information, and you have seen it can be offline and even the real time, like you are continuously adding the information and it is getting saved. So it, though it is providing me all sort of that advantages, but there are some limitations, like the amount of data that I can store here, that can be limited, like few TBs only, right? But what if I have petabytes of or gigabytes of data to be stored, right? So for that I need even bigger database. Again, that will also follow some sort of not a document database, but some sort of database which can store continuous information, like continuously some data is coming and I'm able to store that. Okay, so for that there is another database which is called big table. Have we ever heard about the big table?
That, but no idea about that.
Okay,
Yeah,
so
relational.
yes, yes, Naresh, who was that?
Yeah, Naresh.
Yes, tell me.
Yeah, it's a non-relational database. We use some hash mapping to relate.
Yeah, right, right. Yes, that's true. That is for hash mapping and all. So now we are talking about the big table, which is a NoSQL database. It is a high throughput database, like it can save thousands, thousands and thousands of rows of data. Okay, thousands of rows, you can say, understand, right? So that can be saved every second. The kind of the rate at which it can store the data is very tremendous, and they are very huge databases. I mean, even when you start with this database, you have to have at least minimum 300 GB of data to work with, right? So they are more of the big data scenarios where we are using it, like if you are aware of any other big data services, like you can see here, Scala, HBase, Hadoop. Okay, so Hadoop could be related to, you can say, a big table. Okay, so what they are doing, they are mainly, I mean, the key point here that you need to be aware of when we are discussing big table, it is meant for the real time data processing or the time series data processing. Time series is a keyword. Okay, so it is for the real time analytics for huge workloads. We can save the information about the edtech, fintech, gaming information, the IoT sensor devices, right? So that sensor devices are actually storing the data in big table. And obviously when we are storing the information every second or every millisecond, when you, like suppose I have some cameras installed or multiple thousands of cameras installed in on premises. Now it is feeding the continuous information, right? Where are you going to store that? For that we use this big table. So as I mentioned the term time series data, that is where it matters, right? So the cameras are going to have the time series data, like every second it is capturing something, and then I need to store it. And I should be having some very optimized databases for it. That is where big table is used. Okay. And obviously it has integration with multiple other databases or the other analytics services, which we can explore in later times. Okay, but for now, this is what you need to know. Big table means time series data processing. Okay, fine. So now let's go next. So we have talked about Cloud SQL, Spanner, Bare Metal, Firestore, and Big Table. Now there is one more specialized database which is called Memory Store, and we'll see what does it have. So memory store is more for the application or the web browsers. It is again storing a lot of information, but that is more for the caching purpose. So suppose you are doing some sort of data analysis, which is very compute intensive. Also, if you want to, if you are playing games, so in that also you want to store the session information, like what was the user who's scoring what, okay, their leaderboard, everything that you are seeing, that will be stored into the memory store, cloud memory store. In the backend, they are actually nothing but the Redis databases. Redis database, if you are coming from the Amazon cloud or something, you must have heard of the Redis databases. Okay, so it is able to store hundreds of GBs of data very much easily on those databases. And even bigger advantage that we get here is they are actually faster, like so fast that they can store the data in sub milliseconds. Okay, like 1/10 of the second also they are able to store the data without having any latency errors or anything. Only concern is that whenever we are going to use these databases, we need to ensure they are created very much close to the workload or the other services with which you want to integrate, so that you can have the better advantage out of it. Okay. Okay. And there are multiple other features, obviously, which you get with other databases as well. Like you can see security by default, like we have the only you can enable the private IPs. So this is used mostly with the backend services. Like whenever you are working with some of the, I mean, gaming application also, whenever you work, so you are having these databases in the backend, storing all those information, providing you all the information very easily, because they are more of interacting in the network layer, you can say. That is my understanding. I have not explored from the other side of it, but when we talked about the gaming, so they are working in the network protocols instead of, I mean, the you can say, uh, I mean, they are UDP networks, you can say. Okay, so that is where it works, which is in the backend side of it. Okay, and again, you get this better insights using the monitoring easily. You can back up it, and they are OSS compliant and all. Okay. So what we need to remember with the memory store, they are caching databases, sub millisecond of latency they provide. Okay, so that is what we can get out of it. These databases. Okay. Okay. Now let's move on. Okay. So we covered the relational, non-relational databases and in-memory database. Now let's see on very high level again. Let's see which one to use when. Right. So if you can see here, obviously this particular graphics do not have the Alloy DB, but that is somewhere aligning here, Cloud SQL. Okay, Cloud SQL and Cloud Spanner, within that it will be aligning. Bare metal solution also Oracle database is relational database itself, right? So now let's see where they are good and what could be their use cases. So when we talk about the Cloud SQL, it's a general purpose database, right? You can use it for all sort of small use cases that you have in hand, like web application frameworks, ERP databases, CRMs that we build, right? For the e-commerce and the web application, again for the SaaS application that you want to build and utilize for that. There is a limitation that with the Cloud SQL, you get only there is a limitation of 64 TB of data that you can save, though it is not that small, okay? But depending on your use case, if you are going to have a lot of data to be stored in that format, so you need to plan it well whenever you opt for Cloud SQL database. Okay? Also, it's a regional, a zonal resource. It can be available for one region only, like multi-zonal, but it cannot be replicated, but cannot be made highly available with multiple regions, and that's again restricted with some of its advantages. Okay, so now for that we have the option of Cloud Spanner, which is again very much cloud native for the large scale requirements, and it is providing me a availability or the SLA of 5999s. Okay. Then the good about these databases, again, it's a RDBMS, highly available, okay? And that is high throughput also we are getting here, and suitable for the gaming. Again, the one that we talked about, the big table, and then we also talked about the memory store. So even this Cloud Spanner is also good for storing the gaming information, like the profiles or the session information in the Cloud Spanner. Depends again what kind of application you are developing, and based on that you need to see what are the cons and pros of these databases whenever you are going to apply them. Okay. Similar to that, again for bare metal, it is specific use cases because most of the legacy applications are still using these Oracle databases. Now for that we need to support the migrating those databases and providing this support for Oracle database also, and that's the reason we need to have the solution for bare metal for Oracle database. Okay. Now the next comes is non-relation one, Firestore and Bigtable. We can go with either of it. Firestore is going to have the limitations similar to Cloud SQL compared to Spanner, right? So these two products, Cloud Bigtable and Cloud Spanner, they are proprietary databases created by Google Cloud. Okay, they are for very large scale requirements. They are providing me the high availability. They are more optimized for heavy read and write events. I can perform all sort of reads and writes. So yes, in Bigtable you have to ensure they have advantage of heavy INOps also, IOPS also. So you can keep on writing while you are reading the data, so that can be enhanced whenever you are working with Bigtable. Okay, so it helps in creating your recommendation engines, personalization engines, right? Even for ad tech, whatever Google's advertisement you are seeing, they are actually behind the scene using this Bigtable itself, right? And for the anomaly detection also, like for fraud detection also, we can use this Bigtable. Okay. Now, in case of Firestore, as we discussed, it is more suitable for the real-time syncing. Like you have stored, you are working with mobile application and suddenly the internet is gone. Now the data will be there for the time unless the network is in place. Okay, and once it is there, it will copy the information to the database, and the data will be then removed from the mobile or the web application. Okay, so real-time sync, offline sync will be data store instead of Firestore. Okay. And the last one, again, for memory store, it is in-memory key value store. So again, similar to somewhere you can say a document database, somewhere aligning with that, like similar to Firestore, but not exactly that. It's having one key, and then you can store multiples of value, like you can keep on going with that direction, like kind of dictionary, you can say, right? So that is the behind the scene, that is how they are storing this information. So it is good for caching the data, for storing the session information. Like you can combine the memory store and the Cloud Spanner, or maybe even the Bigtable for the gaming application. Like the session information can be stored in the memory store. The other information can be stored in the cloud spanner. Right? And again, it is suitable for the personalization, keeping the record of the leaderboards whenever you are playing some game. So all those scenario, this database can be used. Okay. So for specific use cases, we come up. I mean, we have to suggest the particular database. Yeah. Okay. So that is probably all about the databases. Now let's see what we have. Okay. Yeah. So this is all about the databases that we have. Now let's. Okay. So anything else that we want to discuss before we kind of conclude today, because we are going to cover the labs day after tomorrow. So anything that I missed or any question that you have in mind?
Okay, so what are the basis to choose any database in the terms of what are the things we have to consider? Suppose that any set of problems or data came, how we will decide it will go in that situation, or what database we will choose?
Okay. So as you asked, Raju, so there are, I need to see what type of database it is.
Okay.
What is the size of the database? Okay. What are my future plans working with these databases, like the amount of data, how much it is going to grow down the line, whatever inputs we have in place. What are my RTO and RPO requirements? Okay, with the
RTO and
databases.
RPO.
Yes,
What is
RTO and
that?
RPO. Okay, so one is a recovery point objective, another one is recovery time objective.
Okay.
Right. So
Okay.
I had explained that in previous session, where the recovery point objective is how fast I can go and recover my data.
Okay.
Recovery time objective is how soon, once the damage happened, once the data center or the data loss happened or any failure happened in the zone or the region, so how much time I can wait before the service is up and again running, right? So that is
Okay.
talking from the future perspective. Like I have already got this failure. Now how much I can recover? How soon I can recover? Not how much, how soon, right? So
Okay.
one is a preemptive approach, another one is a reactive approach.
Okay.
Okay, proactive and reactive, you can say.
Okay. Okay. RTO is reactive.
Sorry.
Recover time objective. RTO is correct.
Yes.
Recover time objective, and RPO is recover.
Okay. It's a recovery time objective, recovery point objective.
Point objective. Okay.
Yes.
Okay.
Yeah.
On that basis, we can consider. Okay.
Yes. Okay. Fine. Any other question?
To give 10 questions for this database also today.
Yes. So the questions that I was preparing, so they were not aligning with the classes. What I will be doing, I will put some effort and align it with the classes as soon as I can do.
Okay.
Okay. So that they can be going together and make you more comfortable while you are working with them.
Okay.
Yeah. So I will put up some time and then come up with that.
Okay.
Yeah. Okay. What else I was thinking about? Yeah. So I'll be sharing with you all the. Give me a second. Yeah. So I'll be sharing the links for today.
Okay.
Day 5, right? So
Yes,
let's
day 5.
have it. Okay. So and I'll also update that in the drive. Fine. So let me first stop the recording.